they're not actually touching the bottom frame, just to give them a little bit of space to breathe and a little extra protection. Now to finish out building the rest of the metal frame, it's time to add the last couple pieces, and this is going to act as a nice railing around the boat edge because I think it's going to be nice when this is on the water. And with that, the top and the bottom frame are firmly attached together and this thing is looking beautiful. Next up, it's time to figure out how we're going to control this on the water. So we're going to need a couple of these, some boat motors. And these boat motors are pretty sweet. They're pretty heavy duty, they got some nice big propellers on the end of them, and they have a decent amount of power to them as well. They're 48 volt motors and 1000 watts of power. And if that sounds familiar, it's because it is. They have the same exact voltage and power rating as the motors that are going to be driving this thing around on land. And I have a pretty strong feeling we're going to find a very similar motor inside of this. And for this project, I am going to be needing to move things around a little bit. Like for one, I'm not going to need the motor controller in here as I'm going to be building a separate box for all of them later. I'm also going to be removing the controls as well as the plastic housing to get this thing down to its bare minimum. And just like I expected, I wouldn't be surprised if this is the exact same motor that's driving us around on land, just happens to be a different color. But that should make this build a lot easier electronically as I should be able to run all of the motors off of the same type of controllers. Now it's time to head over to the vehicle and figure out a way how to attach the motors to it. But there is a problem. I don't really know how deep the floats are going to sink in the water, so I want to design a system so I can move the boat motors up and down however I'd like. And for building that, I got some pretty sweet stuff planned. Starting with a set of these, some linear slider and rails. And these things are just super satisfying, and I chose this one specifically because it completely wraps around the rail, so there's no chance that they'll ever fall off, and you can also get a glimpse of the small little rows of ball bearings in the center. And these ensure that the bearing block slides super freely over the rail, and they just float around with barely any friction at all. Then, to help control how the sliders are going to move, I got this, which is a linear actuator, and these things are really sweet. This one just runs off of 12 volts, and once you plug it in, you can see the front of it just extends on out. Then, if you reverse the polarity, it will go ahead and return to where it started, which is pretty awesome. And these things are actually pretty strong for how small they are. This one's rated for pushing 1500 newtons of force, so it turns out this thing can push a whole lot of newtons. And in case you don't know what a newton is, that's around 330 pounds or 150 kilograms. Which is way more than enough to move our boat motors. Now we can begin the process of connecting them all together, and for this I'm going to be using, you guessed it, some more pieces of steel tubing. And all of these pieces actually came from the motorcycle camper build from when I upgraded all the tubing and turned that vehicle into a car. So it's just cool, I get to reuse some of that as well. And now we can finally combine all the parts together, the sliders, the linear actuator, and the boat motor into one solid unit. And for that, we're going to need the help of the sponsor of today's video, PCBWay. PCBWay is your one-stop shop if you're ever looking for designing custom printed circuit boards, CNC machining, 3D printing, sheet metal fabrication, and even injection molding. And for this project, I'm really interested in the CNC machining. And for every project I've ever built since the beginning, I always try to do something a little bit better, learn a new skill, because there's always room for improvements. And for this project, that means I'm going to learn how to draw in CAD. Because up till now, all my projects have been pretty manual. I'm literally just drawing in graph paper, color coding everything, and I laminate the copies before I go ahead and build them. So it's definitely a pretty big challenge to learn how to use CAD. I've never done anything like this before, but you gotta start somewhere, and I'm still super proud of it. Now for the easy part of uploading the file to PCBWay's website, which is just drag and drop, and they even have a built-in 3D viewer, which I found was pretty fun. Then you can pick what you'd like it to be made from, and because my machine's going to be on the water, I went ahead and picked aluminum. Then they'll machine it and ship it right to your door, and mine arrived quickly and came wrapped up like a big beautiful burrito, and I gotta say, these things turned out looking beautiful. Nice and shiny, perfectly machined, absolutely fantastic. There's just something so cool about designing a part on the computer than just having it materialize on your front door. It honestly kind of feels like magic. And I don't think I've ever been this excited about a piece of metal before. This is my first CNC part that I've ever designed, and I'm super proud of it. Thanks again PCBWay for sponsoring this video, and if you're ever looking for custom parts, printed circuit boards, or anything like that, definitely check them out with the links in my description. And now that we got this beautiful custom part, we can finally assemble all the pieces together, which is super simple as I designed it to perfectly line up with the sliders so I can take some machine screws and tighten it on down. And you can see the thing slides so satisfying. Love it. I also designed the plate so I could attach down another piece of steel tubing, and this part's going to be used to help support the bottom of the motor and also where I can attach the linear actuator.
Bonjour, je suis Eugénie Bastier, journaliste au Figaro. Notre différence, c'est notre liberté de penser. C'est pourquoi...
Now it's time to connect up the motor to the plate, and for that, there's still 2 more holes left on the plate which line up with these mounts on the motor, and these are normally used to hold it down to the side of a boat, but I'm going to be removing them and installing some heavy-duty bolts instead. And these bolts are going to perfectly line up with the holes on the aluminum plate, so I can slide it in place, flip it over to the other side, and tighten it down with some lock nuts to firmly hold it in place. For holding down the bottom of the motor to keep it more secure, I'm going to use a U-bolt as well as a couple pieces of foam that I cut out from some gym puzzle mat so I can place it on the top and bottom of the motor and bolt it down to really squish it in place without damaging the motor. And just like that, our boat slider unit is complete. And since I had 2 motors, I had to make 2 of these units. And of course, we got to test them out using a small little 12-volt battery. And I go ahead and plug it in, and you can see both of the motors are being lowered. I can reverse it to raise the motors back on up. And I gotta be honest, I am so proud with how these things turned out. I've never made anything like this, and they work beautifully. So let's go ahead and get them installed, which is super easy because I'm just using another piece of tubing so I can bolt it to the frame, as well as adding on another piece on the top to really give it some extra strength. And since I have 2 of these motors, the other one's getting installed on the opposite side, so not only does this vehicle have tank steering on land, it's also going to have tank steering on water. Absolutely awesome. And now that we have all the motors installed, it's time to give this vehicle some brains. And for that, I found this really cool case. It's nice and heavy duty, it's got great clasps on it, and it's going to be the perfect size and shape to install all of our electronics for the build, and we got some pretty sweet stuff for that planned. So let's get it all installed. And to help with that, we're going to need a nice strong base to mount everything to. And for that, I'm going to be using some of this yellow cutting board. It's nice and strong, it's non-conductive, and not only is it great for cutting up foods, it's also just a really easy material to work with, as you can just use regular power tools to cut it to the shapes you want, and if you ever need to drill out holes in it, the stuff just drills through like butter. Super satisfying. Then for all of the holes that just got drilled, I'm going to install some of these machine screws that are going to go ahead and screw down nice and flush in place. And all of these machine screws sticking out are going to be the nice and strong mounting points that we're going to attach our electronics to. So let's go ahead and take them and install them in the case. And to help with that, we're going to be using my good old friend Alien Tape. This is probably like my favorite tape. It's just like a clear, thick, double-sided tape, and I just find a use for this in like all my projects. And I'm using it just to initially stick down the cutting board to the case. Then on the other side, I place down a couple more layers of the tape and stick down a 2x4 on top. Then, to make it all nice and permanent, it's back to the inside where I take a drill to drill through the cutting board, the case, into the wood underneath so I can place in some large screws and screw all the pieces together to ensure that the cutting board, the case, and the 2x4 are connected together as one solid piece. And now that we have a nice strong base and mounting points for all of our components, we can go ahead and get them installed, starting with the brushless motor controllers. And these are just gonna control our motors. And since I have 8 motors, I'm gonna need 8 of these motor controllers. And they just slot in place beautifully. Now safety is always important, and since I'm running a bunch of these motors underwater, to prevent any shorting and stuff like that, I got a bunch of these 50 amp resettable fuses, and I'm gonna be installing one of them for each of the motor controllers. Then, for extra safety, I decided to get this really large T-class fuse. This one's rated for 300 amps, and it's going to be running through the whole system just for extra backup. Then, for connecting up all the high amperage currents, I'm going to be using a bunch of these bus bar terminal posts, and these are just going to be installed on the cutting board base as well, just to make wiring the system up a lot easier. The next part to install is going to be this, which is a DC to DC converter. It takes 48 volts and steps it down to 12 volts, so I'll be able to power the things like my boat motor sliders, as well as when I add some external lights on the vehicle, we'll be able to run those as well. And this will just get installed on some machine screw posts right next to the controllers. To help connect up all the wiring and make it just a lot more organized, I'm going to be using a whole bunch of these terminal blocks, which I absolutely love. And since I installed all those machine screws through the cutting board base, it's really easy to hold on all the components, as I could just go around with some lock nuts to really tighten everything down to the frame. We're also going to need some switches so we can actually turn on and off all the different systems on the vehicle, and they're super easy to install in the case. I just take the correct size hole saw, drill out all the different holes, then I'll take some 5-minute epoxy to make it more permanent and pop all the switches in place so that they're on there nice and secure. Looking good. Next up, we don't actually have a way to run wires in and out of the case, so for that, I'm going to be using a whole bunch of these different cable glands. And just like the switches, it's really easy. I just use the correct size hole saw, then I can just drop in the cable glands and tighten them down to the case. And there's definitely quite a few of these cable glands that need to be installed. And also, I just really like the look of them. Nice and clean. And the last thing to install on the side of the case is going to be this nice quick disconnect switch. Absolutely love these. I've been using them in pretty much all of my projects lately, and I'm just going to be installing it with some epoxy as well as some small machine screws so I can really stick it down in place. And this is the port I'll use for charging the vehicle, and if I ever want to run appliances, I can use that port as well. For this next step, I think it's important for the organization that I go around with my label maker to mark all the components so I'll know exactly what each one controls, and that really helps if there's ever a problem and I need to replace a part, I'll know exactly what I'm looking for. Now for the fun part of wiring it all up. And using all these bus bars to connect all the wiring makes it super simple. Now for connecting up all the controllers, as you can see, there's just a whole bunch of wires hanging out here, and to really help organize with that, I'm going to be using some more pieces of cutting board, some machine screws, and a bunch more of those terminal blocks so I can make some really nice connectors for it. And these are going to make it just so much more organized and simpler as I can connect up all the phase wires and power wires for all the motor controllers to them. Looking good.
Yedi kat daha etkili leke giderme ve 2 ton daha beyaz dişler.
Sensörün klinik beyazlığı öneriyorum.
Now that we got the controllers nice and hooked up to the terminal blocks, the last thing to connect to the controllers is going to be the signal wires that are specifically for the throttle and reverse. To make things easier when connecting them up, I'm going to be using a bunch of these plugs that will perfectly fit. So all I gotta do is make up a few custom wire loops with those connectors on the end, so I can head over to all the controllers and just plug all the pieces in place for a super satisfying click of all the controls. Then I can take the output from all those wires, which have some nice color-coded ring terminals, and tighten them down to the terminal block. Then all we need to attach to that is going to be our controls, and I got some pretty cool ones. For one, I got these nice little thumb throttles. These are probably my go-to for handlebar mounted thumb throttle switches. They just feel really nice. And I also have some of these little thumb switches that I'm going to be using for the forward and reverse. So I wired them up by adding some custom ring terminals on the end, so I can bring them over to the controller box, feed them in and up through the cable glands, and connect them on up with nice color-coded wires. Absolutely beautiful. And the only thing left we gotta hook up is gonna be the main power coming in, and then we just gotta hook up the motors. But before that, I think it's about time we install the controller box on the vehicle, which is super simple as I just drill out a couple holes on the 2x4 that line up perfectly with the holes on the steel tubing, so I can just use a couple bolts and tighten it down directly to the frame for a super secure connection. And we have all of our switches right on top for turning on and off our different systems, and we have super easy access to all of our electrical components. So let's go ahead and finish wiring it up by taking all the wires running from the motors, feeding them into the cable glands for both sides of the controller box, and then connect them up to the terminal blocks with the color-coded wires. And the last thing to connect up in here is going to be the main power wires, which happen to be super thick. And these things just get fed up through the bottom cable glands and connected to the main negative terminal and main positive terminal of the whole system. And just like that, we got the main brains of our vehicle built, all nice and installed in this wonderful controller box. Absolutely awesome. But in order to power the brain, we're going to need a pretty big power source. And for that, I have this. A big, beautiful 48 volt 100 amp hour lithium iron phosphate battery. And I've been using these Enjoybot batteries to power all of my builds for the last couple of years, so I know it's going to power this build no problem at all. But since we're going to be on the water, I want to give it a nice protective case, using one of these nice storage containers. And the best way I can think of attaching it to the vehicle is using some more steel tubing. But the hard part is going to be how we're going to actually attach the tubing to the case. So for that, I'm just going to be drilling out a couple holes. Then I made some custom little washers out of some leftover cutting board, and I stuck down some pieces of alien tape onto one side so I could place them over each of the holes that I just drilled out. Then I can take some bolts and push them through the washers to the underside of the case. For the middle holes, instead of bolts, I'm going to be using some long pieces of threaded rod, and these will actually be used to later hold down